Okay, good morning. Good morning, my dear students. Do you know me? Yes, I think you know me. I'm Fernando. Okay, so today I bring you the very interesting topic in your class 11. What is the most important topic in our chemistry? That is atomic mass. So now I just divided here. One is atom, another is the mass, right? Just I separate in two parts. One is atom, another is the mass. Now question is, what is atom? It's not time to explain what is atom because you know. So it's the smallest particle present in an element. So this atom is present in element. So I think you could remember what are the elements. So there are 120, more than 120 elements known by scientists. So some common elements I think you could remember. Say for example, right? Hydrogen. Hydrogen. So what is the name of the atoms present in the hydrogen? That is the hydrogen atom. Very easy, no? Right. Similarly, I just take another atom, element, that is the carbon. What is the name of the atoms present in the carbon? That is the carbon atoms. No doubt. It's simple. Right. No confusion. So here we are going to find out what is the mass of the atoms. Yes, we know different atoms have a different mass. See, be careful. You have to be very clear. See, hydrogen, the atomic mass of the hydrogen, the atomic mass of the carbon should not be same. That means different atoms have a different mass. Okay, but how to know that how much the mass of the hydrogen atom? That means what is the atomic mass of the hydrogen, what is the atomic mass of the carbon? That is the very important here. Now here I just say the atom I write here, mass I write here. So what do you mean by atomic mass? Is the mass of an atom. Now here, what is the atomic mass? Mass of an atom. Okay. So now here, how do we find out the mass of an atom? See, very easy. I think you know. Okay, when you go to the market, when you go to buy the something in your shop, in your market, say suppose rice. How do we buy the rice? See, we used to take the some amount of the rice we used to buy, right? So in our tradition, some using the some containers we take the rice, but in the shop what we used to buy in two different way. One is collecting the some container or just using the weighing balance. See, if I require 1 kg of the rice, so the shopkeeper does not give it simply by just picking with their hand. So they used to take the weighing balance. So weighing balance like this, right? So now on one side they put the rice, okay? They put the rice. On other side, I think you can see. So they used to take the some reference mass. That means reference mass means known masses, okay, which are universally agreed, right? What are the reference mass available in their shop? I think they have the 500-gram stone. Okay, I think you understand it. And the 1 kg stone is there. Okay, 2 kg stones there, 3 kg, okay, 5 kg stones are there. By using such a reference masses, we can take the 1 kg of our rice. So on one side they put the rice, on other side they put the reference mass. They can use the 500 gram. So if we are going to buy the 1 kg, if they have only 500 gram stone, so they can put a 500 gram stone put on one side, and they will take the rice and just put it on that side and just see the how is that balancing, right? Once that two side is same balance, So that is the amount what we took it 1 kg. That is the rice, 1 kg of rice. Okay, that's the way how do we find out the mass of this something. That means my conclusion is that when we take the mass of substance, we used to take the reference mass, right? Okay, so now here in order to take the atomic mass of an atom, so here also we take a reference mass. Okay, could you imagine? Yes, I asking you, could you imagine what is our reference mass in order to find the atomic mass of an atom? Yes, try to remember it. Could you find? I think when you open your book, I think you could find out one reference mass. It's not mentioned in the book. Okay, that is the reference, but I mentioned to you that is the reference mass. So what the reference mass you found? That is atomic mass unit. Atomic mass unit. So in short, we used to write AMU, right? So AMU in our chemistry, that is the atomic mass unit. So but this short, I mean abbreviation in our some of the one of the very famous university also using, that is the Aligarh Muslim University. So this is not Aligarh Muslim University, this is the atomic mass unit, right? Now here, so you please understand what is the atomic mass unit. So please say simply, sir, this is the reference mass in order to find the atomic mass of different atom, right? So now here, so one atomic mass unit, how much gram equivalent? See, as we know that 1 kg of stone, 1 kg, so how much gram equivalent to? That is 1000 gram equivalent. Similarly, 1 AMU, how much gram equivalent to? So I write here 1.66.056 into 10 to the power minus 24 gram. This much gram equivalent to 1 atomic mass unit. So this atomic mass unit also known as verified mass or verified unit. Sometimes we write U. When we do calculate the atomic mass of our non-element, suppose atomic mass of the hydrogen. So how much the atomic mass of the hydrogen? It could be 1.008 something, right? So that is AMU. This mass AMU, the mass, atomic mass of the hydrogen equivalent to. So now here, so this is the atomic mass of the hydrogen. So by that way, so it sometimes we can write 1.008 EU also, right? So now I repeated here, what is the reference mass in order to find the atomic mass of an atom? That is the atomic mass unit. Now how much gram equivalent to? 1 atomic mass is 1.66 into 10 to the power minus 24 gram, right? So don't forget. Now here, the most important thing is here in our elements. So these are the simplest substance. All these substances are available in our universe, right? Okay, so the atoms present in our elements, that is different from the atoms of different elements, right? Now here, when I talking about the atoms, atoms. So what is the atoms? We know is the small particles. Now in the small particle, these atoms consists of 3 subatomic particles. Another small particles are present in the atom. These subatomic particles are, what are they? So I write the protons, another is the electron and another is the neutron here. So there are 3 subatomic particles, right? One is proton, another is electron, and the third one is the neutron, right? So what is a proton? So you can answer in a very simplest way. This is the unit positive charge, right? I write a positive charge. And similarly, what is an electron? Okay, electron is an unit negative charge. I write negative charge. And what about a neutron? Neutron is the neutral, no charge, right? Either positive charge, no, neither positive nor negative charge. That is, I put it here 0. Okay, these three subatomic particles are present in our atoms. Now here in the atom, at the center, a very concentric part is there. That concentric part, I just showed you that diagram. This is the center. This is the very concentric part. Okay, very thick and very concentric one. This concentric part in our atom. Okay, what is to be called? That is nucleus, right? Okay, nucleus is the concentric part of our atom. What is the charge of the nucleus? That is the positive charge. Why then positive charge carried by the nucleus? Because one of the subatomic particle is present here. What is the subatomic particle present in our nucleus? That is proton. Okay, not only the protons present, another subatomic particle also associated with the proton, that is the neutron. Okay, clear? And around the nucleus, okay, an imaginary circular part are there. Imaginary circular part. That imaginary circular part we call orbit. In that orbit, electrons are revolving. Electrons are revolving. Okay. Now, in that way, how the atoms are. Okay. That now here, see in our atom, okay, the number of the protons present, this number of protons present in the nucleus is always same with the number of the electrons revolving around the nucleus. Don't forget, I repeat it again. In our atoms, the number of the protons present in our nucleus, right, and the number of the electrons revolving around the nucleus, it should be same, not different. It should be same, right? So now that number indicates the number of the atoms, right? So now here, that number, what we generally call atomic number. Atomic number. What is the atomic number? Okay, atomic number is the number of the protons or number of the, okay, electrons. See, you know, in the nucleus, what the charge of the nucleus carried, that is the positive charge. This positive charge we consider as the nuclear charge. How many nuclear charge carried by that atom? That number is also the atomic number, because this number, okay, is always, okay, remain unchanged. Here, the number of the proton and number of electron is always same in our atom. Okay. Now, this atomic number is different in different elements. Say for example, carbon. Okay, what is the atomic number? I write the symbol Z. What is the atomic number of the carbon? Do you remember? Yes, you know it. What is the atomic number? That is the 6. Okay, so what it does mean 6. Okay, the number of the 6, I mean the 6, what is we call atomic number. What it does mean, that is the number of the proton or number of the electron or number of the nuclear charge, right? So here is the element when we are talking about the nitrogen. Okay, what is the atomic number of the nitrogen? That is the 7. That means this number of the protons of the nitrogen, this number of the protons present in the carbon, it's always different. That means the atomic number of different elements are different. Okay, if the number of the protons different, obviously the number of the electrons also be different. But in our universe, elements are available in the form of the different states, like in the solid form, in the liquid form, or in the gaseous form. Yes, I said before, carbon, you know, carbon is okay, available in our universe, okay, in the form of the solid, right? See, hydrogen is also available in our universe. In what the form, in what state of the, okay, I mean in what state this hydrogen is available? That is, the hydrogen is the gas, right? So similarly, some other elements are, okay, in solid form, some are, okay, in the liquid form, some are in the gaseous form. Here, these, okay, gases, I mean these elements which are available in our universe, so in their element, I mean in the elements, right, the atoms, okay, can be different, right? What is different in their atom? That is the number of the neutrons. I write number of neutrons, okay. This number of the neutrons can be varied. So if the number of the neutrons different in their atoms, right? So that atom also be different in the same element. I repeat it again. So in an element, I mean in one element, in an element, the type of the atoms can be varied, can be different. Why the atoms are different? Because the number of the neutrons present in the nucleus can be also different. If the number of the neutrons are different, so different types of the our elements available in different atoms, that types of the, okay, properties of the elements we call isotopes. What is it? Isotope. Yes. What do you mean by isotope? Isotope is the properties of an element, right? What it does mean, okay? Different atoms of the same element. I mean, one element can have different atoms, right? So different atoms of the same element, okay, having the same number of the protons. So the number of protons is same in the different atoms, but different number of the neutrons present in our nucleus. Right. I repeated, what do you mean by isotope? So isotope is an properties of an, okay, element, right? So what type of the properties of an element? That is the different atom of the same element. Okay, what is that? Different. Okay, having the same atomic number. Same atomic number means number of the protons present in the nucleus, but different in the number of the neutrons. Don't forget, right? That types of the properties of the elements we call, okay, isotopes. Here, one more idea I just share with you, right? Okay, different isotopes of the element, okay, different isotopes of an element have a different chemical properties. I remind you again, okay, different isotopes of an element having the different chemical properties, right? Then now another thing, we have a different, okay, atoms of elements, different elements we have, right? But their physical properties are, okay, completely different. Their physical properties different, okay. So what is the properties of the elements known? That is, we learn allotropes. One is the isotope, another is the allotrope. Same as isotope is also properties of the element, allotrope also properties of the element. What is the difference between the isotope and allotrope? Very simple is that. So these isotopes of the different, I mean, isotope means different atoms of the same element have a different chemical properties. Okay, now here allotrope is the, okay, atoms of the same element, right? Okay, having the different physical property. Here is the physical properties. Okay, here is the chemical properties. So you please understand this logic, okay? Normally you just will learn, okay, only, okay, on the basis of chemistry we learn, okay? So we forget, we neglect the logic, we neglect the concept, okay? So this is the concept, this is the logic, what we should understand that. So here I just tell you, isotope and electrons are the properties of the elements. What are the properties of the elements? Different atoms of the same element. Here are also different atoms of the same elements, right? But what the difference here in the isotope, okay, these atoms having the different chemical properties, right? But in the different atoms of the same element, here the different physical properties, right? So we know, example, carbon, you know. What are the allotropes of the carbon? Very distinct difference of the allotropes of the carbon. We know one is the graphite, no? One is the graphite, another is the, you remember, that is the diamond. Both are carbon. Yes, graphite, name different, diamond different. So you just simply add that the diamond is the, okay, one of the substance. We don't know what the element belonging. And graphite is also another substance, but what element it's related, so we don't remember, we don't understand. I think it's to create a lot of confusion here. So graphite and the diamond both are carbon, so these different atoms present in graphite and diamond here. Only the thing is that their physical properties are totally different, yeah? So now in the isotope here, in our carbon also we have a different atoms of carbon. So I write carbon 12, carbon 13, carbon 14, right? I write here this 12. So this 12 here I should mention here. I want just write here atomic number here. So the atomic number of this, all these carbon are same. What is the atomic number of this carbon? Is the 6. What is the atomic number? Is also 6. Here also 6. As I said before in our isotopes, right? Same number of the protons. But what's the difference? Different number of what? Different number of what? Neutrons here. So now in our nucleus, two particles are there. One is the proton, another is the neutron. You know, okay, the protons carry the positive charge, no charge in the neutrons, right? How many protons are there? How many neutrons are there? If you know the atomic number of the given element, that number is related to the number of the protons here in the carbon. That is the 6 plus. What should be the this 12? 12 is the number of the proton plus the number of the neutron. What is the number here? That is the 6. 6 number of neutrons here. This sum of the number of the protons and the number of the neutrons present in the nucleus, that is what we call the mass number. Right? So I write the mass number, I write A. A is the mass number. So when we write the symbol of an element, the perfect designation of element, the perfect designation of the symbol which represent the element. So we write carbon, okay, with the atomic number we write here, and with mass number we write here or here. No doubt, we can write just before and after that. So now here, the atomic number of all these three carbons same. So no need to mention here also 6, here also 6, here also. Since the number, okay, what's number? Mass number is different. So we mentioning here, this mass number is 12, this mass number is 13, this mass number is 14. Now here, this mass number I write A. So this 12 is represent the mass number, this 13 is the mass number, this 14 is the mass number. Here, one more conclusion we found here. What do you mean by isotope? That is the different atom of the same element, right? Different atom of the same element, okay, having the same atomic number but different mass number, right? So that is also we call it isotope of an element, right? Now here, so these isotopes here, carbon 12, carbon 13, carbon 14, right? So what is the number of neutron here? 6. That means when we do calculate, that means 12 minus 6, that will come out 6. When we do calculate here, 13 minus 6, that will come out 7. When we do calculate the number of neutron here, 14 minus 6, that will be the 8. So here, number of neutron here is the 6, number of neutron here is 7, number of neutron here is 8. So these are the number of the neutron present in our carbon atoms. Yes, right. Now here, these different atoms of the carbon have a different chemical property. They have different chemical properties. Okay, don't forget. Now here, I give you one more example of the isotopes here. See hydrogen. You know hydrogen. So we have three different atoms of hydrogen, right? Three different atoms of hydrogen in our universe. One of our hydrogen atoms present in our universe, that is the protium, right? So protium, what is protium? Protium is an isotope of hydrogen, that means hydrogen. So now number 2, deuterium. Then number 3 is tritium, right? These three are, see, names slightly different. I mean, names totally different from our name of the element hydrogen, right? But though the protium, though the deuterium, though the tritium, when we have all these three are hydrogen atoms, right? So can I ask you, what is the protium? Protium is the hydrogen atom. What is the deuterium? Deuterium is the hydrogen atom. What is the tritium? That also hydrogen atom, right? But only the question is, what are the difference, right? How are they different here? See, since this is the hydrogen, this also hydrogen, this also hydrogen, right? What is the atomic number? That means what is the number of protons present? 1. What is the number of protons present? 1. What is the number of protons present? 1. I write number of protons. That means if you know the number of protons, what is the atomic number of this hydrogen? This hydrogen, I said 1, right? And now if these are the atoms, in the atoms, number of protons and number of electrons, it's always same. Now here, I think no need to ask you, what is the number of electron, what is the number of electron, what is the number of electron? Okay, so all these three number of electrons are same. That means 1, 1, 1 here, right? But the protium nucleus, I write this protium. What is the symbol I write here? This symbol I write is D. I write it D. This I is represent the protium. This D represent the deuterium. This E represent the tritium. So atomic number is same. No need to mention 1, 1, 1. Only the difference is their number of the neutrons. Okay. So when we find the number of the neutron, we write here the mass number. What is the mass number of hydrogen here? 1. What is the mass number of this deuterium is 2. What is the mass number of this 3? That means we have a 3 hydrogen atom. One is the hydrogen 1, another hydrogen 2, another the hydrogen 3. These 1, 2, 3 are the mass number of the hydrogen atoms respectively. You know. Now here, if you know the mass number of these hydrogen atoms, could you find out the number of neutrons? Right? Could you find out the number of neutrons? Okay, as I just give you the mass number, you know the mass number is the number of protons plus number of the neutrons. Okay, so from that simple formula we can calculate the number of the neutrons. See, mass number here is 1, number of proton is given here 1. What should be the number of neutrons? Just you find out for the respective our isotopes of the hydrogen. And now just I ask to you, out of this, out of this isotope, one of the isotope, there is no any number of neutron. So please find out what nuclei. What nuclei is given here? Nuclei is given here. protein nuclei, deuterium nuclei, tritium nuclei, because in the nucleus, right, number of neutrons is present. Which of the following three, which of the three isotopes of the hydrogen, okay, no neutrons present? You please find out in your copy, okay? That is the question for you. Yes, now, my interest is, okay, my interest is not this one. My interest is, right, see what? In our universe, if we have a different atoms of the same elements, right? So if we have a different atoms of the same elements, right? So we don't, okay, it's not possible to have a, okay, different atomic mass of the same element. Okay, one more, I just remind you, okay? So for one element it should be one atomic mass, right? But we have a different atoms, okay? So if we have a different atoms of the same element, how could we have the, okay, only one atomic mass, right? So here, that's how we do calculate. So if we have a number of the isotopes of our element, that means more than one isotope, it should be, okay, every element in our universe available, they have their different isotope. Similarly, hydrogen can have a 3, carbon can have a 3. So okay, other element also, nitrogen also, okay, different element can have a different number of the isotopes, right? Now here, these isotopes are available in our universe, understand? In our universe means in the atmosphere, or in the form of the solid, in the form of the gas, in the form of the liquid, that are available in different form of the atoms, right? See, hydrogen also, so these three hydrogen also available in our atmosphere, right? So but among these isotopes, okay, so their abundance means how much available, right? So are not same, some are very plenty, some are very few, some are very rare, right? That means how much they are available in our universe can be expressed in terms of their relative abundance or relative proportion in our universe. So now, as I said before, so one element should have one atomic mass, right? But since they have a different atom, how could we find out their a single atomic mass? So that is the very important. We know that is what we calculate, that is average atomic mass. This average atomic mass, okay, that is the, okay, when we have a different, okay, atoms of the same element, that means different isotope, I should say. So if we have a different isotopes of an element, so we going to find out their a single atomic mass. That single atomic mass we are going to calculate, that is what we call average atomic mass. This average atomic mass is related to their isotopic mass. Yes, how do we calculate the atomic mass? Okay, just before these topics we discuss about atomic mass. You know atomic mass. So we took the reference mass, no, atomic mass unit, right? By that method, by that techniques, we calculate what is the atomic mass of different atoms. So here hydrogen, deuterium and tritium 3 can have different masses. So what the mass of this, I just used to calculate, that is the, this mass, I think it's supposed to be somehow, greater than this value, supposed to be this one greater than these two values, right? So we have a different atomic mass of different atoms of the hydrogen, but in our chemistry we should have only one atomic mass of the hydrogen, right? So these isotopes, right, so we require their isotopic mass when we do calculate their average atomic mass. if we know the atomic mass of the hydrogen, if we know the atomic mass of this isotope, I mean deuterium, if we know the atomic mass of this tritium, so when we do here, suppose I write atomic mass of the X, atomic mass of this Y, atomic mass of the K, T is the 3. So how do we calculate the average atomic mass? This is the X plus Y plus now Z. So now how many isotopes since we can write 3, then we can find the average mass. This is a simple mathematical calculation. How do we calculate? You know, that means when we calculate the average atomic mass, we do find out their atomic, I mean isotopic masses, right? If we know that their isotopic masses, so all their atomic isotopic masses, we try the sum of them divided by number of isotopes, that is 3. Then what the numbers form, that is the atomic mass of the hydrogen. We can use it. Simple logic. But now here, these isotopes of the different elements are available in our universe in different abundance. Some are very high abundance, some are very less abundance, right? Since their abundance, I mean their proportion in our universe is different, so when we do find out their average atomic mass, we can't neglect their proportion. That means how much the proportion they have it and they are available in our universe. So one simple formula, I just do it here. Average atomic mass, right? Oh, right. Average atomic mass. How do we calculate? You please understand, I am going to write something. Okay, what I am going to write their atomic masses. So now I write the isotopes. I am going to write isotopes of an element. How many isotopes is given here? I write X, Y, and Z. Right? Okay, and their relative here, I just before I do the I write a formula. Just I write what are the isotopes. I write X, Y, Z. Okay, and their isotopic mass. Let me write their isotopic mass is X, Y, Z. Right? How many isotopes? I consider 3 isotopes. Right? Okay, what are the isotopic mass of these 3 isotopes? I write X, Y, Z. No, simple. And these isotopes, we just consider 2 key things. What we approach. Number 1, relative abundance. This relative abundance, it's sometimes given in the percentage, right? It's given in a percentage, or it can be expressed in relative proportion. Just giving by the some value, some number, some figure. Say suppose so just I write K, L, M. These are their relative proportions. Suppose 1, 2, 3 like this, right? So if they have given their relative proportion, how much ratio is given here like this, right? K, L, M like this, right? So if the relative proportion or relative abundance, suppose it may be right, here is the 10, that is the 20, and here is the 70, almost that is the percentage, 100. Okay, so now here the relative abundance is given here 10%, 20%, that is the 70% they are available. See now here, so we have 3 isotopes. One is suppose A, B, C, right? What are the isotopes of this? Okay, A is the isotope, B is the another isotope, C is the another isotope of the one element. What are the isotopic mass of A? Isotopic mass of the A is the X, isotopic mass of the B is the Y, isotopic mass of the C is the X. And what are their relative abundance? Suppose they are given in the percentage, suppose they may be given with the 10, 20%, 70%. So instead to write this number, let me write a K, L, m, right? This may be present, this may be given in the percentage, right, like this, or it can be given in the relative proportion. Let's write a 1 is to 2 is to 3 is to something like that, right? So now here, you please understand, you please listen very carefully when we do calculate the average atomic mass. Okay, number one, we should remember that what are the isotopes given. Number two, what are their isotopic masses and how are their relative abundance, right, or relative proportion. So suppose I take it here, one of the elements, having the three isotopes. What are the isotopes? A, B, C. Similarly, hydrogen, Similarly, if we take the hydrogen here, hydrogen, protium, deuterium, tritium, right? Their isotopic mass is given here. Their isotopic mass is X. Isotopic mass will be given to you. Suppose this is the hydrogen 1 point something to 1 point something, 1 point something. The value is given here. If we know the isotopic masses, what I use here, the letter X, Y, Z, right? And their relative abundance is given either in the percentage or in the proportions here, right? If suppose they given the 10%, 20%, 70%, that number I just write KLM. If you know that their isotopic mass, if you know the relative proportion or relative abundance, how do we calculate their average atomic mass? The simple formula is here. See, I show you. Average atomic mass of an element given. Number one, what is the isotopic mass? I write for the A. I write X is the isotopic mass of the A. What is their relative abundance? In proportion, or it may be abundance in percentage. Suppose K, I write only write K plus, right? Now if I write the B, right? What is their what is the isotopic mass of the B? That is the Y, right? And what is the relative abundance of the B? That I already given there L, right? Plus, what is the isotopic mass of the C? That is the Z, multiplied by K. Its relative abundance is the M, right? Then divided by their relative abundance, their relative proportion, the sum of them, K, L plus M. This is a simple formula. We can calculate their average atomic mass. Okay, so this simple formula you can remember and you can calculate from their isotopic mass plus their relative abundance. That example you can see in the textbook is given there, in some questions are given even in your competitive examination, like NEET or very advanced one Z, for engineering and for medical professions. For you have to appear the competitive examination. In that examination, these types of the concept they put up and they asking this question here. So the thing only that you remember that how we calculate the average atomic mass. I just put a very important one, right? Very important. So only the simple idea I just share with you. How do we calculate the average atomic mass? The first requirement is their isotopes. What are their isotopic masses and how are their relative abundance, or in percentage or in their proportion, right? So if these isotopic masses and relative abundance are available, we can calculate their average atomic mass in a very simplest way. Their isotopic mass given multiplied by their abundance in percentage or something given there. That is the another isotopic mass given and multiplied by the abundance. Then isotopic mass given multiplied by abundance divided by total sum of their relative abundance. that we could find here. Okay, average atomic mass. Don't forget. So you can practice, okay, by using the some examples given in your, okay, text. I mean NCERT textbook. You can find out very nice questions given. So then if you don't understand, you can send any message through me. Then I'll just give you hand. Okay, I help you, right? So this much you try to understand, okay, about the average atomic mass. Okay, this much. Okay, then see you then, right?